Welcome to the Shika Serbu Motor channel. This channel provides easy-to-understand explanations of car mechanisms. This video informs you the latest trends in hybrid vehicles and plug-in hybrid electric vehicles. In recent years, the world had been all about EVs. It seemed like, eventually all cars would become battery EVs. However, around 2023, the tide began to turn. Battery EVs are still increasing, but their growth rate has started to decline. Automobile manufacturers who were EV proponents were alarmed. They won't be able to meet the CAFE regulations, corporate average fuel efficiency, and will have to pay hefty fines. Mercedes-Benz has not only given up on full electrification, but they also predict that even by 2030, the sales share of battery EVs and PHEVs will not reach 50%. Ford announced that by 2030, they will introduce hybrid vehicles across all their internal combustion engine models. Yes, the party is over. If you want to know why the party is over, please watch the video, All the Bad Points of Battery EVs. The link is in the description. It is impossible for anyone to accurately predict the future 5 years from now. But it seems certain that hybrids will become more prevalent. The new players to emerge will likely be mild hybrids and parallel hybrids. Hybrid vehicles are broadly classified into mild hybrids and strong hybrids. In mild hybrid vehicles, the role of the electric motor is starting the engine, assisting the engine during launch and acceleration, as well as to recover energy through regenerative braking. The electric motor alone cannot drive the vehicle. They use an ISG, integrated starter generator, that combines the starter motor and alternator. Generally, a device placed in the position of a traditional alternator is referred to as a BSG, belt-driven starter generator. In one position between the engine and the transmission, is referred to as an ISG. For learning more about ISG, please watch the video, How a Starter Motor, an Alternator and an ISG Work. For the 48-volt electrical system used to drive the ISG, watch the 48 volts car electrical system. Links are available in the description. In strong hybrid vehicles, the electric motor not only performs the roles of a mild hybrid, but also drives the vehicle solely on electric power at certain speeds. Therefore, they are equipped with a higher output electric motor and a larger capacity hybrid battery, compared to mild hybrid vehicles. Strong hybrids include power split type, series type, and parallel type. The power split type is used in Toyota THS and Renault E-DEC systems. In terms of fuel consumption, this system is the most efficient. The series type is used by Nissan e-Power and Honda 2-motor hybrid. In this system, the engine is used solely for generating electricity, while the vehicle is driven only by the electric motor. However, in Honda system, the engine drives the vehicle at high vehicle speeds, where the efficiency of the electric motor decreases. The parallel type is used in Ferrari and Porsche, among others. Not for reducing CO2 emissions but for achieving higher output. If you want to learn more about the classification of hybrid vehicles, please watch the video, Hybrid Systems, How It Works. The link is available in the description. PHEV stands for Plug-in Hybrid Electric Vehicle. PHEVs are equipped with higher output electric motors and larger capacity hybrid batteries than strong hybrid vehicles. As long as there is battery charge remaining, they can travel even on highways using only the electric motor. Same as strong hybrids. There are power split, series, and parallel types. The power split type is used in vehicles such as the Toyota Prius and RAV4. The series type is used in vehicles such as the Mitsubishi Motors Outlander. The parallel type is used by automobile manufacturers such as Stellantis and Mercedes-Benz. In the past, hybrid vehicles were mainly dominated by Japanese manufacturers' series hybrid and power split hybrid systems. Moving forward, particularly by European manufacturers, it is predicted that mild hybrids will be introduced primarily in affordable models. In parallel, PHEVs will be adopted for other categories. Let's take a look at how parallel type PHEVs operate. The current parallel type PHEVs employ a one-motor two-clutch system, which includes clutch A that connects the engine to the transmission, and clutch B that connects the electric motor to the transmission. When there is sufficient battery charge, clutch A is disengaged, separating the engine from the transmission. The vehicle operates using the electric motor from launch and accelerating to driving on highways. However, the engine also operates when the vehicle reaches a certain speed on the highway or during rapid acceleration. When the battery level falls below a certain threshold, the PHEV operates as a hybrid vehicle. When the vehicle is stationary, the engine is off and the clutch A is disengaged. For launch, only the electric motor is in operation. During acceleration, when the vehicle reaches a certain speed, the clutch A engages, and the engine is started by the electric motor. During steady speed driving, the electric motor stops operating, and the vehicle runs on the engine alone. When strong acceleration is required, the electric motor output is added to the engine output. During deceleration, the electric motor is worked as a generator to charge the battery. The battery can be charged from an external charger. While there is battery charge, and the vehicle is running solely on the electric motor, CO2 emissions are at zero. However, after the battery charge is depleted, it becomes an inefficient hybrid vehicle laden with useless heavy batteries. The Mercedes-Benz E350e is a parallel PHEV with a one-motor two-clutch system. The engine is a 2.0 liters, four-cylinder turbo engine, producing 150 kilowatts or 204 PS, and 320 Nm of torque. The electric motor generates 95 kilowatts or 129 PS, and 440 Nm of torque. The transmission is a 9-speed step type, and the battery capacity is 19.5 kilowatt-hours. The Peugeot 408 is also a parallel type PHEV with a one-motor two-clutch system. The engine is a 1.6 liters, four-cylinder turbo engine producing 132 kilowatts or 180 PS, and 250 Nm of torque. The electric motor generates 81 kilowatts or 110 PS, and 320 Nm of torque. The transmission is an 8-speed step type, and the battery capacity is 12.4 kilowatt-hours. The Range Rover Evoque is a PHEV with a unique drive system. The 1.5 liters three-cylinder turbo engine, producing 147 kilowatts or 200 PS, and 280 Nm of torque, along with a 54 PS BSG, belt-driven starter generator, drives the front wheels. And the electric motor, generating 80 kilowatts or 109 PS, and 260 Nm of torque, drives the rear wheels. The transmission is an 8-speed step type, and the battery capacity is 15 kilowatt-hours. The Lexus RX 450h Plus is a power split type PHEV. The 2.5 liters four-cylinder naturally aspirated engine, producing 136 kilowatts or 185 PS, and 228 Nm of torque, along with an electric motor generating 134 kilowatts or 182 PS, and 270 Nm of torque, drives the front wheels. The rear wheels are driven by a separate electric motor, producing 40 kilowatts or 54 PS, and 121 Nm of torque. The transmission is an ECVT of THS, Toyota hybrid system, and the battery capacity is 18.1 kilowatt-hours. The Ferrari 296 GTB is a parallel type PHEV, with a one-motor two-clutch system. The engine is a 2.9-liter six-cylinder turbo engine that produces 488 kilowatts or 663 PS. The electric motor generates 123 kilowatts or 167 PS. The transmission is an 8-speed DCT, and the battery capacity is 7.45 kilowatt-hours. Volkswagen has announced the Golf GTE, but its release is expected to be in late 2024 or possibly 2025. According to reports, it features a 1.5 liters four-cylinder turbo engine, with a total system output of 200 kilowatts or 272 PS, paired with a 6-speed, DSG, dual-clutch transmission, and a battery capacity of 19.7 kilowatt-hours. Thank you for watching. If you enjoyed this video, please consider subscribing to the channel. We'll see you in the next video.